today's lesson, we are going to use the division method to find the greatest common factor of a group of numbers. This method is very similar to the division method used to find the least common multiple. Therefore, if you have not watched that video, I would highly recommend you watch that video first before coming and watching this. Let's say we have a group of numbers 4, 16, 20, and 24. And we wanted to find out the greatest common factor of these four numbers. We would start off by dividing, and our goal would be to find one number that could divide all four of these numbers. Again, when dealing with greatest common factor, we are only interested in the numbers that can divide all of our numbers. So for example, in the least common multiple, we had to divide at least two numbers in every step, and that was the minimum. Here, while dealing with greatest common factor, you must have a number that divides all the numbers that are given to us. If it only divides two or three of them, we are not going to take that into account. So starting with our set of numbers, I can start by dividing with 2. So I'll get a 2 here, 8, 10, and 12. Now in the following step, I can divide by 2 again, and I would be able to divide all four of them. I can divide this, I'll get 1, 4, 5, and 6. Now remember, if we were working on the LCM method, I would continue dividing because I would be able to divide 4 and 6 by 2. But because this is the greatest common factor, again, we are only interested in the digits that can divide all of our numbers, not just 2, 3, all of them. So in our case, 2 and 2 were able to divide all of our numbers. Therefore, the product of that, which is 4, is the greatest common factor. Now, what if we had another set of numbers, such as 16, 20, 30, and 48. I would start off by dividing, and the first thing I would look for is there one number that can divide all four of them? Given how these are all even numbers, 2 is a very safe place to start. So I can start with 2, 10, 15, 24. Now, can you think of one number that could divide all four of them? Chances are that you won't be able to find one single digit that can divide all of our numbers. Therefore, this would be my greatest common factor, 2. Let's try another example. If I had to find the greatest common factor of 5, 20, 25, and 30, let's start by dividing, and 5 would be a good place to start. And this is what I would get. But I would not proceed any further because no number can divide all of these numbers without leaving a remainder. Therefore, 5 would be my greatest common factor. Now imagine we had this set of numbers, 6, 12, 15, and 20. If I had to find the greatest common factor of these numbers, I would need to find one number that could divide 6, 12, 15, and 20 without leaving a remainder. And if you do some calculations, you'll see that there isn't a number that can divide all of them. Now you can say, well, what about 1? As we mentioned in the least common multiple video, when doing least common multiple and greatest common factor, we don't take 1 into consideration, as 1 can be the greatest common factor of most numbers, and 1 is a factor of basically all numbers. Therefore, 1 does not get counted. But because we can't come up with any other number other than 1, the set of numbers 6, 12, 15, and 20 have no greatest common factor because we can't find one number that would divide all of them.